Work on memorizing the basic trig identities, and we're going to talk about how memorizing just a select few will help us build a ton of other information. So the very first thing I ask you is, what would the reciprocal identity, so I'll call it the RI, reciprocal identity of sine be?
1 over cosecant.
1 over cosecant theta, right? Okay, so we'll say that's the first one you kind of need to have memorized. Second one, what is our reciprocal identity of cosine theta?
1 over secant theta.
Yeah, 1 over secant theta. Which leaves, what's the last one?
Tan theta equals 1 over cotangent theta.
Beautiful. Okay, so with that information, okay, just memorizing those three, can you tell me what secant theta might be equal to?
1 over cos theta.
Yeah, we just do the reverse, right? We flip the other one over, so we get 1 over cos theta. And the way that's tactically derived is you could think of it like cross multiplying. Okay, cos over theta could be a fraction, and then we cross multiply. Well, 1 times 1 is 1, and then you have secant and cos on this side, and then we just bring cos to the other side, so you have 1 over cos theta is equal to secant. Right? It's just simple algebra. What about the other two?
Cosecant is equal to 1 over sine.
Cosecant theta equal to 1 over sine theta. Good.
And cotangent 1 over tan.
Easy. Good. Okay. How about what's known as, we'll call it our second set here, and this will be the fourth thing we need to memorize. It's known as the quotient identity. So we'll call it QI. Do you know what the quotient identity is?
Sine over cos equals tan.
Good. Sine theta over cos theta equals tan theta. Now, with this being said, you could build a ton of stuff. What can I build from this? Just off the top of your head, what do you think we can build?
Sine is equal to tan over cos.
Sine theta is equal to tan over cos?
Or tan times cos.
Yes, that's right. Tan theta times cos theta. That's good to know. Okay. What about this is a tougher one. What would cos theta be equal to?
Cos theta is equal to...
I'll give you some arrows to help. Say I have cos over here. I want to get it by itself, so I have to move tangent. What do I have to do?
It's not sine over tan.
It is.
Oh, it is. Okay.
It is.
Because is there there's that 1 under tan theta over
yeah,
1? Okay.
Yeah, sine theta over tan theta. That works. And I'm going to give us a couple other ones. What about cotangent? You know what cotangent would be equal to?
Tan over sine?
Tan over sine? Will that
or
work? No. Technically, no, it won't quite work. Think of the reciprocal of these two.
It would be cos over sine.
Yes, cos theta over sine theta. So it's easy to build other ones. We just flip this one, because cotangent is the inverse of tangent. Yeah. And then from there, I can say cos theta is equal to cotangent theta times sine, right? Sine theta. We can also say that sine theta, okay, using this concept, is equal to cos theta over cotangent theta. Again, all of these ones I've done in blue, there's absolutely no reason to memorize any of them. You memorize this, and you can build 1, 2, 3, 4, 5 extra identities out of that one we wrote in black. Okay. The last one we'll go over. So, and there's technically 3 in these, so we'll call them 5, 5, 6, and 7. Okay, so there's 7 identities. They call them the Pythagorean identities, so we'll call them PI. Okay. Can you name one of them?
Sine squared theta.
Yeah, sine squared theta.
Plus cos squared theta. Equals 1.
Equals 1. Good. What about another one?
Secant. Squared theta.
Yeah.
Minus tan squared theta. Equals 1.
Yeah, which leaves?
Cosecant theta minus cotangent theta.
Hey, very good. Good. And what happens with all of these is they usually show like 9 of them, okay? And really all they are, okay, is moving values to one side or another. So along with this, I can say sine squared theta is also equal to 1 minus cos squared theta. And the reason I can say that is because I just moved cos to the other side. Or we could say cos, see if I can fit it in, squared theta equals 1 minus sine squared theta. I didn't quite fit it, okay? But that's a third one you can pull from that. And then you can do the exact same thing again here. What would secant squared theta be equal to? Do you know?
1 plus 10
Plus,
squared
good.
theta.
Plus 10 squared theta. Okay, and here's the harder of the two. What would tan squared theta be equal to?
1 minus secant squared theta.
Close.
Secant squared theta minus 1.
Yes. Now, do you know why that happens? What happens here is if you're starting from here, okay, if we have this tan squared, when I move secant over, it becomes subtract secant squared theta, okay? But I also have a negative tan. So think of it like we have to multiply by -1 both sides. And then this becomes subtraction and this becomes addition. Another way is to just look from here, okay? We need to get tan by itself, like we said. So I just got to move 1 to the other side. You can think of each of these as one step to the next step. And each of them are technically an identity. Okay, so tan theta is equal to secant squared theta minus 1. And then finally, give me 2 more for this.
Cosecant theta is equal to...
So you can squared theta.
Yeah, squared theta.
Yeah.
Is equal to 1 minus cotangent squared theta.
When I move this negative cotangent to the other side, what will it become?
Oh, 1 plus.
Yes. Cotangent squared theta, which means, what's cotangent squared theta equal to?
Would be 1 minus cosecant.
Try moving from this step here. So cotangent squared. Right? We want this by itself. So when I move 1 to the other side, it becomes
-1.
Yeah. So we got.
Oh, so 1 minus.
Yeah. So you could say, you'd say cosecant squared theta minus 1 or -1 plus cosecant squared theta. Either are fine. Cosecant squared theta minus 1. Okay. So there is already a plethora of identities. What did we come up with? Something like 8 here. 1, 2, 3, 4, 5. 5 extra 6, 7, 8, 9, 10, 11, 12, 13, 14, plus the 7, 21. You have 21 identities by just memorizing 7, and we can actually build a ton more out of them, okay? As long as we have those ones in black memorized, then we're probably okay.